Hello everyone, let's look at this problem here. We want to take the derivative of this function. And when we want to take the derivative of this function, we actually want to rewrite each of the terms so that it's in the form of x to the some power. It's really because we need to apply the general power rule for each of the terms here. And if we don't do that, then we cannot actually take the derivative. Maybe we can, but we got to use the quotient rule for this one. But we can actually just rewrite it so that we don't have to use the quotient rule. Okay, so let's get started here. So first step, I'm going to rewrite the function. And when I'm rewriting the function, I'm just writing down f. I'm not writing down f prime, right? As you can see here, this is still f. This is the same function, but it's just going to look different. And so we are going to just copy down the x square because that's already in the right form. And for the second term here, we are going to bring this x square up to the top so that it becomes x to the -2. Okay, and then the third turn we don't need to bring it up or down, right? Because that's already in the numerator, and all we need to do is to change the square root into an exponent, and that actually is what x to the 1/2. Okay, what about the last term? The last term is going to be um, having a negative exponent because the cube root of x is in the denominator, and so before we bring it up, we actually want to just think about what this thing looks like, right? This actually looks like x to the what? 1 over 3. Okay, so let me just rewrite that 1 over 3 here. Okay, so if you bring it to the top, and then it's going to become what? X to the -1 over 3. Yeah, because that x to the 1 over 3 is in the denominator, so if you bring it up, then it becomes this thing. Okay, so now we are ready to take the derivative because every term is in the right form. Okay, so next step, we are going to do f prime of x, right? And what are we going to get here? We are going to, when we apply the general power rule, we are going to just bring the 2 down, bring this -2 down, bring this 1 over 2 down, bring this -1 over 3 down. And so they all become a coefficient. And so we are going to get 2 and then x. Now, when we apply the power rule, we actually need to subtract 1 from the original power to obtain the new power. So we are getting, let me use this the different color here, which is what? 2 minus 1. I'm actually just showing the calculation right here. And then the next one is actually -2, right? We are bringing down the -2, so the coefficient is -2 right here. And then what do we get here? We are going to get x to the, what is that? That's -2 minus 1. Continue. We are going to get 1 over 2, right? We are going to get positive 1 over 2, and then x to the, what is that? That's 1 over 2 minus 1. And so far, so good. And last one is that we are going to get the -1 over 3 is the coefficient, and then x to the, what is that? That's -1 over 3, and then we subtract 1 from it. Okay, so that's basically the derivative. But we do want to simplify a little bit of this answer so that it looks better, right? As you can see here, there are some calculations that are really obvious, but that's not done yet, right? So let's do some cleanup of this. And then we are going to get what is that? That's 2x to the first power, right? 2 minus 1. 2 minus 1 is really just the first power, so we're just going to leave it there. And what about the next one? The next one is going to be minus 2x to the, what is that? That's -3. Okay, -2 minus 1. And then third term here, we are going to get 1 over 2. What is that 1/2 minus 1? 1/2 minus 1, we need to get the common denominator for this. And so as you can see here, when we look at that, that's actually 1 over 2 minus 2 over 2. So we are going to get -1 over 2. Is that okay? And so we have x to the -1 over 2. Then lastly, we are going to get -1 over 3. And then again, we gotta get the common denominator for this one. It's going to be -1/3 minus, we turn the 1 into a number with denominator 3, so we are going to get 3/3. So that's actually -4/3. Yeah, so we have x to the, what is that? That's -4/3. Okay, so that's our final answer and our somewhat simplified answer. And if you do want to go further with the simplification here, we can actually do something to the exponents, right? So that they are not negative exponents. We can do that. And what we can do is to just move them to the bottom and also write the fraction exponents as radicals. And I can do that right here just to show that. And then we can just do that quickly. So we are going to get 2x, right? And then minus. Now bring the x to the -3 down to the bottom. So we get 2 over x to the third power. And then plus 1 over 2. Now, what about this x to the -1/2 here? You bring down, you are going to get x to the +1/2. And a +1/2 will actually give you a square root. So we get x to the, we get the square root of x. Okay, lastly, we are going to get this. What is that? That's actually the cube root of x, right? That's the cube root of x. And we have a fourth power of the x also. So we are going to get the cube root of the x and then x to the fourth power. Okay, so that may look better depending on the situation, but if you need to, let's say, find a critical point or critical numbers of this function, then you actually will need to do something here. What do? We actually need to get the common denominator and then put them all together, right? We combine them all and then we are going to put it as a single fraction. Then you can find the critical numbers more easily in that case. Okay, so that's it for this problem. And thank you for watching. And if you like this video, please subscribe to my channel and give me some support. And I will continue to make more videos on mathematics. Okay, so thank you. See you next time.